classification of elements and periodicity in properties. Students, I think you have studied about periodic table in class 10th. This is the periodic table. Total 118 elements are there. There are total 118 elements. It is known as the modern periodic table. But students, first of all, many scientists came and they gave their views about the periodic table. So today we will see the historical development of the periodic table. Historical development of the periodic table. Okay. In this day we are going to study periodic table. We are going to study 118 elements. We are going to study 118 elements. But what is the history behind that? How they get developed? We will study today. Dobereiner Triad law. Students, a number of elements are there, so it is difficult to read the elements individually. So many scientists came and they gave arrangement of the elements in different way. Some scientists gave the arrangement of the element on behalf of their properties. In 1800, there were 13 elements only. And in 1865, there were 63 elements. Means day by day, new elements were discovering. Okay. So students, first of all, in 18th century, Dobereiner gave us law for arrangement of the elements. Dobereiner put the elements in order of the atom, in order of increasing atomic mass of the element. He arranged the element in order of their increasing atomic mass. Increasing order of their atomic mass. Okay. Then he found that a group of element which have similar physical and chemical property, in that group, three elements, if we take the group of three elements, then atomic mass of first and third element in a triad is approximately equal to the atomic mass of second element in the triad. Dobereiner Triad law states that according to Dobereiner, when elements are arranged in order of increasing atomic mass, we will arrange the elements in order of increasing atomic mass. Then arithmetic mean of the atomic mass of first and third element in a triad is approximately equal to atomic mass of the second element in the triad. What do you mean by this? Here you can see. Here lithium, sodium and potassium. Okay. Lithium, sodium and potassium. According to Dobereiner, they are making a triad. Triad means because Dobereiner worked on three elements at the same time. So we are using the word triad for 3 elements. Okay, because this law was given by Dobereiner, so it is known as the Dobereiner triad law. Okay, so first triad was lithium, sodium, potassium. You know very well. What is the atomic mass of the lithium? It is 7. And atomic mass of sodium is 23. And atomic mass of potassium is 39. So Dobereiner said that if I arrange these elements in order of their increasing atomic mass. So here sodium has least atomic mass, then sodium and potassium has highest atomic mass in between these 3 elements. Okay. So according to Dobereiner, arithmetic mean of first and third element. Here first element is lithium and third element is potassium. So calculate arithmetic mean of masses of first element and third element. So mass of lithium is 7 and mass of potassium is 39. We want to calculate mean. How can we calculate mean? We will add sum of all given numbers divided by total number. Okay, so there are 2 total. So it is 46 by 2 and it is equal to the 23, and 23 is mass of the middle element. It is mass of the sodium. So according to this law, when we increase the elements in order of their increasing atomic mass, then average atomic, or we can say arithmetic mean of mass of first and third element is nearly equal to the atomic mass of middle element. It is clear to you or not? Any doubt in this? Okay, you can take one more example. Second triad is calcium, strontium and barium. Calcium, strontium and barium. Here calcium has if atomic mass 40. Calcium has atomic mass 40, strontium has 88 and barium has 137. So if we arrange them in order of their increasing atomic mass, so calcium has least and barium has highest. So here first and third element mean we will calculate. So 40 plus 137 divided by 2. So this is the arithmetic mean of first and third element. Okay, and it is 88.5 and it is nearly equal to the mass of the middle element, mass of the strontium. It is clear to you or not? Okay, you can take one more example. Third triad is, first triad is lithium, sodium and potassium. Then second triad calcium, strontium and barium. And third one triad is chlorine, bromine and iodine. Here chlorine atomic mass 35.5, bromine 80, iodine 127. If I arrange them in order of increasing atomic mass, okay, then atomic mass of first element plus atomic mass of third element, it is 35.5, it is 127. Okay, then calculate arithmetic mean of them. So their arithmetic mean we will divide total sum by the 2. Okay, it is 81.25 and it is nearly equal to the atomic mass of middle element. It is nearly equal to mass of the bromine. Clear to you or not, students? So in Dobereiner law, one thing you will learn that atomic mass will be in increasing order. We will take increasing order of the atomic mass. We will arrange the element in increasing order of atomic mass. Then atomic mass of middle element, second element, will be nearly equal to the average atomic mass of the first and third element. Any doubt in this law? Okay, but this law had some limitations. Limitations of the Dobereiner Triad. First limitation is that many new elements were discovered in 18th and 19th century, which made the classification of elements in Dobereiner Triad difficult and also impossible in some cases. Students, some elements which were not discovered at the time of the Dobereiner, but after that they got discovered. Okay, and if we want to fit that element in according to the Dobereiner, then it was impossible to fit them according to Dobereiner law. Okay, so that was the limitation of the Dobereiner. Second one limitation was only 5 Dobereiner triad could be identified and new elements could not be grouped in Dobereiner triad. Means only 5 triads formed. Or I can say that one triad has 3 elements and 5 triads will have 15 elements. So it was applicable only for 5 triads. Only 5 triads were there. And we were able to make more triads. We were able to make the more triads. Okay. So it was also the limitation of Dobereiner triad. It is not possible for all the elements present in periodic table. There are also exist several elements at time of Dobereiner triads formation that did not fit into the Dobereiner triad. Students, even some elements were discovered at time of the Dobereiner. Already some elements were discovered at that time. And Dobereiner triad law was not fitted in them also. It was not applicable for those elements also which were already discovered at the time of the Dobereiner. It is clear to you or not? Any doubt in this point? Okay. Now, it resulted in disorder element collection. Some elements are arranged in disorder, means in irregular order they were arranged. Okay, all elements were not arranged in a regular pattern there. So this was also the limitation of Dobereiner triad law. Then some other scientists also given their views about the table, about the classification, about the arrangement of the elements. Okay, and one of them was Newland. Newland gave the law of octaves. Because this law was given by Newland, so it is known as Newland. Law of octaves. Because Newland was doing work at 8 elements at the same time. At same time, he was working at 8 elements. So this is known as the Newland law of octaves. It is clear to you or not? What does this law states? When elements are arranged in increasing order of their atomic masses. Again we are arrange the element in increasing order of atomic mass. In increasing order of the atomic masses. Only in modern periodic table we are arranging the elements in order of increasing atomic number. Okay, before that we were arranging the elements in order of their increasing atomic mass. So first thing, Newland also arranged the element in order of their increasing atomic mass. Clear? The property of eighth element are a repetition of the property of first element. Means after eighth element, properties are getting repeated. The property of first element and eighth element at respect to the first, their property should be similar. Their property should be similar. Okay, how can you say that? For example, if we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium. So you know very well, here 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. Here lithium has 2, 1. Atomic number is 3. And here sodium has atomic number 11. Both have 1 electron in their outermost shell. So both has tendency to lose 1 electron. So their properties are similar. So after 8th, property of first element and property of 8th element, both are similar. So what was Newland law saying? It was saying that property of eighth element are a repetition of property of the first element. Newland divided the element into horizontal rows. Each horizontal row had 7 elements. You can see. This table was given by the Newland. Okay. So Newland arranged the element in horizontal rows in this way. 1, 2. In this way he gave. He arranged the element in horizontal row. He arranged the element. One row had 7 elements. 1, 2, 3, 4, 5, 6, 7. Okay. And he was saying that property of hydrogen and fluorine are similar. Property of fluorine and chlorine are also similar. Okay, and you can see that it is 1, 2, 3, 4, 5, 6, 7, 8. So properties of first element, let us consider it is fluorine. Okay, so with respect to this, chlorine is 8th element. So according to this, properties of first element and 8th element are similar. This law is clear to you or not? Any doubt in this? Okay. So there were 7 elements in one row. This law also has limitation. What was the limitation? It was applicable to only lighter elements. This law was applicable only for the lighter element having atomic mass is up to 40. Means it was applicable only up to calcium. Only up to calcium it was applicable. After calcium, first and the 8th element did not have the similar property. Means I can say that this law is not applicable after calcium. It is applicable only up to calcium, up to atomic number 40 units. So this was the major limitation of the Newland law of the octaves. Okay students, so today we have discussed 2 laws. Okay, Dobereiner law of Triad law and Newland law of the octaves. And tomorrow we will discuss some more laws like Mendeleev periodic table. Then we will go on modern periodic table. So thank you. Have a nice day.